Hi, mathletes! Today we're going to find the greatest common factor. So in this video, we will explore how to find the greatest common factor, also known as the GCF, of two or more numbers using factor trees. As we work through examples, we'll learn how to break down numbers into their prime factors, use factor trees to visualize the process step by step, compare prime factorizations to identify common factors, multiply shared factors to find the GCF. So let's discover how prime factors help us find the greatest common factor of two or more numbers. We'll start with the example of the greatest common factor of the number 12 and 18, and we can do this by making a factor tree. If you haven't seen my video yet on how to make factor trees, you can use the QR code to the right. So now let's find the greatest common factor of 12 and 18. We'll start by making a tree with the number 12. What two numbers can I multiply to get to 12? 3 and 4. Since 3 is prime, I'll circle it. 4 is composite. So what two numbers can I multiply to get 4? 2 and 2. And since 2 is prime, I will circle both of them. Now let's look at 18. What two numbers can I multiply to get 18? 9 and 2. 2 is prime, so I circle it. What two numbers can I multiply to get 9? I can multiply 3 and 3 is also prime, so I circle them. Now we're going to write down the factors of 12 and 18. So the prime factors of 12 is 2 multiplied by 2 multiplied by 3. And the prime factors of 18 is 2 multiplied by 3 multiplied by 3. Now you might be wondering why I didn't put this 3 underneath the 2. And it's because when I put a number underneath, it needs to be the same number as the one above. So that's why I needed to make an extra column with the 3. So now I divide these into columns. And to find the greatest common factor, I bring down a number that has a number in both the top row and the second row. So notice I'm bringing down the 2. I will not bring down a second 2 because this one is empty. But I will bring down the 3. I cannot bring down this 3 because, again, there's no 3 up here. So then we multiply the 2 and the 3, and the greatest common factor is 6. So we'd say the GCF of 12 and 18 is 6. Now let's try the same thing, but this time we have 3 numbers. We have 8, 36, and 48. So let's make a tree with 8. What two numbers can I multiply to get 8? 2 and 4. 2 is prime, so I circle it. For 4, what two numbers can I multiply to get 4? 2 and 2. And again, they're also prime, so I circle them. Now let's look at 36. What two numbers can I multiply to get 36? 18 and 2. I circled the 2 because it's prime. 18 is composite, so what two numbers can I multiply to get 18? And I can multiply 9 and 2. Again, 2 is prime, I circle it. 9 is composite, so what two numbers can I multiply to get 9? And it's 3 and 3, and 3 is prime, so I circle both of them. Lastly is 48. What two numbers can I multiply to get 48? 12 and 4. Both of those are composite, so let's start with the 12. What two numbers can I multiply to get 12? 4 and 3. 3 is prime, so I circle the 3. What two numbers can I multiply to get 4? 2 and 2, and again, 2 is prime, so I circle both of those. And now I go back up to my 4 here, and what two numbers can I multiply to get 4? And it's 2 and 2. And again, they're prime, so I circle them. All right, now we're going to list them out. So for the prime factorization of 8, it's 2 multiplied by 2 multiplied by 2. For 36, it's 2 multiplied by 2 multiplied by 3 multiplied by 3. Again, notice I didn't put my 3 under the 2 because they have to match up. So I had to make 2 extra columns. And now we have our 48. And I have 2 multiplied by 2 multiplied by 2, and then multiplied by 3. But I had an extra 2, so I had to put it at the end because I didn't have a 2 to put it underneath. Now I make my columns. And to find the GCF, this time the entire column has to be full. So see how this is completely full? So I can bring down the 2. And then I'm going to multiply that by, and this is also full, so I can bring down another 2. But this one is not full. This one is not full. It's missing up here. Not full and not full. So the GCF is 2 multiplied by 2, or 4. So the greatest common factor of 8, 36, and 48 is 4. Again, remember that the column has to be completely full to bring it down. So the greatest common factor is the largest number that divides evenly into 2 or more numbers. To find the GCF, we used factor trees to break down the numbers into their prime building blocks. We identified which factors they had in common. We multiplied those shared factors then to get the GCF. And we solved problems with both 2 numbers and 3 numbers. So math isn't just about the answer. It's about understanding the process and seeing how the numbers connect. Thank you for watching. And if you like this video, click a like, leave a comment, or better yet, subscribe. Thank you again, as always.